Okay, so this is chapter 17 in my book, Overcoming Digital SAT Math by Sophia Garcia. And this is going to be the word problems chapter. So this is like a mix of a bunch of different word problems on a bunch of different skills. So let's get started. So for number 1, pause to read if you haven't already. So let's call the number of mangoes M and the number of peaches P. So we could say that 0.45 times the M number of mangoes plus 0.95 times the number of peaches has to add up to $9 or less, obviously. So if she buys 7 mangoes, so M is equal to 7, and actually instead of equals, let's change this to an inequality symbol to make it even more accurate. So we're going to say it has to be less than or equal to 9. So if M is 7, so I'm going to plug in 7 for M, we're trying to figure out what's the biggest number that P can be, basically. So I'm going to start by multiplying this out and then subtracting it from each side. So that's going to be 3.15 plus 0.95p is less than or equal to 9. So now I'm going to subtract 3.15 from each side, and that's going to give me 5.85. So now I have this, and now I just need to divide by 0.95 on each side to get p completely by itself. Now, when I do that, I'm going to get like 6.157, yada, yada, yada. So I'm going to just say it's 6.115, I don't know, 8, because it's 1.157. The neighbor is 8, so we'll just round up to this. So I'm going to get that has to be greater than or equal to P. So P has to be less than or equal to that value. Now, you can't just go to the store and buy like 6.1 peaches. So the maximum number of peaches that she can buy is going to be 6. So that's your answer there. Okay, pause to read number 2 if you haven't already. So we know that Sally and her empty truck weigh 5,000 pounds, right? Then we have to add on the weight of all the crates. So each crate weighs 20 pounds. So to find the weight of all the crates, it would be 20 times the number of crates, C. And then the bridge in Washington has a weight limit of 8,000 pounds. So now we have that this is 8,000 pounds. And now we just have to think about the inequality symbol that goes in between. So if $8,000 is the limit, or not $8,000, sorry, 8,000 pounds is the limit, then that means when we add all this up, it could be equal to 8,000 or it could be less than that. So this is what it's going to look like. So now we're just going to subtract 5,000 from each side and solve for C. So then I get 20C when I subtract 5,000 from each side is less than or equal to 3,000. Now I just need to divide. Ooh, that kind of looks like a 0. I meant to make that a C. Then I have to divide each side by 20, and that's going to look like this. Now I can cancel a 0 there and a 0 there, so I can say C is less than or equal to 150. So what's the maximum value for C? Well, the most it could be is 150. And I just realized I forgot to show that, that I went over here and wrote that, sorry. So the greatest that C could be is 150, so that's your answer, 150. Okay, so pause to read number 3 if you haven't already. So we have 36 plus 6y is 14 less than 84. So it equals a number that is 14 less than 84, which is just going to be 70. Now I have to subtract 36 from each side. That's going to give me 6y is equal to 34. Then I want to get what 3y is. So I'm going to divide each side by 2, because then that'll turn this into 3y, because 6y divided by 2 is 3y. And then divide this by 2, that's going to give me 17. So 3y is equal to 17. So now, to find the quotient of 153 and 3y, I'm going to do 153 divided by 17. And that ends up equaling 9. Okay, pause to read number 4 if you haven't already. So I like to think of these problems as, these mixture problems as part plus part equals whole problems. And what I mean by that is, like you take the parts, like the solutions you're mixing together, think of those as parts, and then like the whole solution that you get, think of as your whole. So if we're thinking of part plus part equals whole, it would look like this, where M is the liters and for the 10% solution, and N is the liters for the 30% solution. And then if you mix that together, the total volume would be M plus N times the concentration, or like, I think that's called a concentration. Don't quote me on that. Would be times the 0.20, because it's 20% chlorine solution that it results in. So we know that Tom is using 20 liters of the 30%. So it says N is representing the liters for the 30%. So N we're replacing with 20, which we can do over here as well. And then now we're going to find out what M is. That's what we're being asked to find. So let's distribute this 0.20 to each of these terms and then multiply 0.3 times 20. And this is what you get when you do that. Now I'm going to subtract 0.1 m from each side. And now I'm going to subtract 4 from each side. And then I'm going to divide by 0.1 to get m by itself. And that gives me that m equals 20, so 20 is your answer. Okay, so pause to read number 5 if you haven't already. So Andy's initial amount of books, remember they were equal initially, so Andy's initial amount is equal to Gary's amount now minus the 20 that Andy lent to Gary. So we could switch that up to get G by itself by adding 20 to each side, and we could say A plus 20 is equal to Gary. Basically, like Andy's initial amount plus 20 books equals Gary's amount now, and we could replace the G over here with A plus 20. So now we just have to solve for A. 3A minus 60 is equal to A plus 20. Subtract A from each side, and then I get 2A is equal to, I could add 60 to each side. 2A is equal to 80. Divide by 2 to solve for A, and you get A is 40. Okay, pause to read number 6 if you haven't already. So if 5 is subtracted from 4 times x is represented by this, 4x minus 5, and that equals or is 27, the question's asking us, okay, once you find x, plug it in here to figure out what the value of 10 added to a fourth of x is, which is represented by that equation right there. So let's solve for x and then plug it in. So let's add 5 to each side to get 4x by itself, and that's going to be 32. And then divide by 4 on each side to get x by itself, and that'll be 8. So we're going to plug in 8 for x right there. So it's going to be 1/4 times 8, which is going to be 2 plus 10, which gives you 12. So 12 will be our answer. Okay, pause to read number 7 if you haven't already. So we just need to plug in the given information into the given equation. So T is the total cost, which is 2,500, and that's going to be equal to 50 times the number of B bottles, which we know is 20. So we're going to plug in 20 for B, plus 10 times R. So I just need to now solve for R. So it's going to be 2,500 is equal to, and then that's going to be 1,000, and then plus 10R. So now I'm going to subtract 1,000 from each side, so then it's going to be 1,500 is equal to 10R. If I divide by 10, I get that R is equal to 150. So that's the answer. So now pause to read number 8 if you haven't already. So 3 is added to the square root of x, and you get 7 as your sum. That's what that means. And we want to know what is the value of x plus 4. So let's find out what x is and then add 4 to it to answer. So root x is going to be equal to, I'm going to subtract 3 from each side, and that's going to give me root x is equal to 4. Then I have to square each side to get rid of that square root. So then I get x is equal to 4 squared, which is 16. And then x plus 4 would just be 16 plus 4, which gives me 20 as my answer. Okay, pause to read number 9 if you haven't already. So H is the calories in the hot dogs, and P is the calories in the pizza slice, in each pizza slice. So pizza slice is equal to hot dog plus 100 calories, like 100 calories more than a hot dog. And then three pizza slices times the calories per slice, that gives you the calories from the pizza there. And then we would add on the calories of 2 hot dogs would, for the 2 hot dogs would be represented by 2 times the number of calories in each hot dog H. And we add that up, we have to get the total amount of calories being 2,000. So this is just a system of equations where we're solving for P, essentially. So I don't want to replace P, I want to replace H. So I'm going to subtract 100 from each side to get H by itself, and then I'm going to do substitution. So I know H is equal to that, so instead of H, I could plug in P minus 100. So let's do that. So 3P plus 2 times P minus 100 is replacing H is equal to 2,000. Now let's do distributive property right here. So then it's going to be 3P plus 2P minus 200 is equal to 2,000. So then 3P plus 2P is 5P. 5P minus 200 is equal to 2,000. And then you're going to add on 200 to each side to get 5P by itself, and that's 2,200. Now divide by 5 on each side to get P completely by itself. And when you do that, you're going to get 440. And that's your answer. And I keep forgetting to move the phone because I'm trying to keep my handwriting better. I'm sorry. So basically what I did right there is I just did exactly what I said. I added 200 to each side, and then I got this. And then I divided by 5 on each side, and I got this. So now pause to read number 10 if you haven't already. So let's call these 3 numbers x, y, and z. So x plus y plus z, the sum of the 3 numbers is going to be 960. And one of the numbers x is going to be 60% more than the sum of the other 2. So x is equal to, and then it's going to be 60% more. So we're talking about 100 and 60% of the sum of the other 2. So 1.6 times y plus z. Because 160% as a decimal, you just move it 2 to the left and get 1.6. So we're trying to solve for what x is. So I'm going to try to replace this y plus z, and I'm going to do that based off of the first equation. I see if I subtract x from each side, If I subtract x from each side, I get y plus z is equal to 960 minus x. So now instead of y plus z, I can plug in 960 minus x, and I have only one unknown x to solve for. So x is equal to 1.6 times 960 minus x. So let's distribute 1.6, and when we do that, we get this. Now I'm going to add 1.6x to each side, and I get this. Now I'm going to divide by 2.6 to get x by itself. So when I do that, I get x is equal to 590. I'm going to put approximately 590.769, yada, yada, yada. But remember, it says round to the nearest whole. So I'm going to say that my answer is 591 because the nearest whole number is 591. Okay, pause for read number 11 if you haven't already. So if x is the number of children's tickets and y is the number of adults' tickets, if we want the total price for the tickets, we would say it's $3 for every one of the children's tickets times how many children's tickets it is. And then we're going to add on $4 for each of the adult tickets times the number of adult tickets they get, and say that that has to be within 15 and 20 inclusive, like this. Now, we do get the number of adult tickets, Y, they tell us is 2. So let's rewrite this. And when we rewrite it, we get this. So now, I just need to solve for x. So let me subtract 8 from each side. And that's going to give me 7 is less than or equal to 3x, which is less than or equal to, if I subtract 8 from this side as well, I get 12. Now I'm going to divide by 3, so I'm going to get 7/3. And divide by 3 over here, and that's going to be 4. Now 7/3 is between 2 and 3. Remember, x represents the number of children's tickets, so you can't just buy like 2.2 tickets or something, like, you know? So we have to think logically about this. If this is a number between 2 and 3, meaning a little bit more than 2 but less than 3, the lowest amount that they could buy would be the 3 tickets to fit this criteria. So x has to be basically, we're essentially saying that x has to be between or including these values, meaning it could only really be like 3 or 4. So that's what your answer would be. It could be 3 or it could be 4. Okay, so now pause to read number 12 if you haven't already. So they're open all the time, it's saying, and there's 2 days that it's open, so 24/7 for 2 days essentially. And they're in 30-minute intervals that they're selling these time slots. So that means every hour there's 2 slots available because there's 2 30-minute slots that fit into an hour. So every day has 24 hours, meaning there are 48 slots per day. So 48 slots per day. And then we are saying that this is happening for 2 days. So then that's going to give us 96 slots as our answer. Okay, now pause to read if you haven't already. So all we're doing here is plugging in the given values into the given equation. So T, the total shipping cost is $60,000, so that's what I'm putting in for T. And then it's 10 times the S number of summer boxes. We're solving for S. And then plus 20 times the number of winter boxes, which is 2,000. So now I just need to say, okay, that's 60,000 is equal to 10s plus, now I just need to multiply this, and that equals 40,000. So now I'm going to subtract 40,000 from each side. That's going to give me 20,000 equals 10s. Divide by 10 on each side, and I get 2,000 for s. So it's also 2,000 summer boxes, so that's the answer. Okay, pause read number 14 if you haven't already. So we're just setting up a direct proportion with our inches as units matching on top and nickels as units matching on the bottom. Now the reason I have 33/5 is because I just went ahead and turned that into a improper fraction by multiplying 5 times 6, then adding 3 to get the numerator. So 5 times 6 is 30, plus 3 is 33, and keeping the bottom number 5 as my denominator. Now I just need to cross multiply, and that's going to give me 33/5 times x is equal to 60 times 15. So now I just need to do 60 times 15 divided by 33/5. So let's write that out nicely. Divided by 33/5. And that'll give me what x is. So when you do that, you're going to get that x is equal to like this whole long decimal basically, and it's like 136.3636 yada yada yada. So we want to know what's the best estimate. So what is this closest to? That would be D, 136. Okay, pause read number 15 if you haven't already. So this would be the setup of an equation that tells you, so basically there's 3 pieces of luxury soap weighing S pounds each. So to get the total weight they're buying, it would be 3 times S. or the total number of pounds they're buying more specifically, would be 3 times S. And then you're going to multiply the number of pounds times the price per pound, which is going to be $4.50 or 4.5 to get the amount they're spending on luxury soap. And then you would apply that same logic to the bath bomb situation. So there's one bath bomb, which weighs B pounds. So 1 times B is just B, and that tells you how many pounds we're talking about buying of the bath bombs, times the price per pound, 6, and that gives you the amount that they're paying for the bath bombs that you're going to add on to get the total amount they're spending on all 3 pieces of the luxury soap and 1 bath bomb, which equals 105. Now, we're supposed to assume that S and B are integers. Like, you can't just buy like half a bath bomb or something like that. So, knowing that, and that we have these answer choices available to us, we might want to start plugging in some of those answer choices to see what could potentially work. So let's start with A, with B being 4. So that would mean it would be 6 times 4, which is 24. And let's go ahead and multiply this out. So 4.5 times 3. So that would be 13.5S. So we're going to just add that on here. Ooh, that's 13.5S. And then we're going to subtract 24 from each side. And that gives us 81. So then we're going to divide by 13.5 to get S by itself. And when we do that, we get S is equal to 6. So this situation works because both of those would be integers. So we could say A is possible, but let's just show how this is not going to work for the other options. So let's say that we're going to put 5 in for B. So that's what I'm doing here. I'm showing how B doesn't work. And so this is 13.5S. I know that's kind of hard to read. So this is going to be plus 30. Now I have to subtract 30 from each side. And that's going to give me 13.5S is equal to 175. Now I'm going to divide by 13.5 on each side. And when I do that in your calculator, you're going to get basically like 5.55, repeating. So that is not an integer because it's not just like, it's an integer is, think of it as like you're counting numbers and they're opposites. So like 1, 2, 3, 4, 5, 6, 7, 8, like those, and like the negative options. Obviously you can't have a negative amount of bath bombs. So this doesn't work because it includes like a decimal or fractional amount with it, so it's not an integer. And you would see the same thing happen for C and D. Okay, so let's do number 16 now. Pause to read if you haven't already. So if we set up an equation for the scenario, the games that she won in all would be 6 games that she started winning plus the X games that she wins later on because she wins all those games. And then you have to add that onto your total as well because there were 20 games that she was playing in total at first, and then she's going to play X amount of games that she wins all of. So that's the wins to total number of games. And that has to equal 1/2 because she's winning half. Like wins to total would be 1 to 2, 1/2. So now I'm just going to cross multiply and solve for what X is. So now I'm going to have 2 times 6 plus X is equal to 1 times 20 plus X. So that's just 20 plus X. Now I'm going to distribute. 2 times 6 is 12. 2 times X is 2X. And then that's equal to 20 plus X. Now I'm going to subtract X from each side. So I'm going to get 12 plus X is equal to 20. Now I'm going to subtract 12 from each side to get X completely by itself, and I'm going to get that X is equal to 8. So that's my answer. So pause to read number 17 if you haven't already. So if I want to find out the fraction of the total students that are undecided, it would be represented by this. I would just subtract the students that are attending vocational school, the ones that are going to a traditional university, and the ones that do not plan on attending college. So I could say that my common denominator, my lowest common denominator, I don't know if it's the lowest, but whatever, it's going to be 30. That's just the first number coming to my mind. So 30 over 30 is the same as 1. And then 3 times 10 gives me 30, so I have to do times 10 on top. And then 5 times 6 gives me 30. So I did times 6 on the bottom. I have to do times 6 on the top. And then 6 times 5 gives me 30, so I have to do times 5 on the top as well. So then I get all of this that I just need to simplify to find the fraction that are undecided. And when I do that, I get 9 over 30 undecided. Now I can obviously simplify that by dividing by 3 on top and bottom, and that's going to give me 3/10. So 3/10 are undecided of the total amount of students. Let's call the total amount of students X, which is what we're solving for. So I know 3/10 of the total amount of students X is going to be 30 students that are undecided. So now I just need to divide by 3/10 on each side to get X by itself. And when I do that, I get X is equal to 100. So the answer would be D. Okay, pause to read 18 if you haven't already. So if we're writing out these situations as equations, 4 subtracted from 2 times the number y is 2y minus 4, and that equals the result 28. And then the question is asking what is 1/3 times y minus 6, essentially. So if we find y from this situation, we can then plug it in here to figure out what the answer to the question is. So let's do that. Let's add 4 to each side. That's going to give us 2y is equal to 32. Then we're going to divide by 2 on each side. So that's going to be 16. And then so I'm going to plug in 16 for y right there. And then that's going to be 16/3 minus 6 equals the answer to the question. So now, this is the same thing as 6 over 1, but if I'm subtracting with fractions, I have to make sure I have a common denominator. So I'm going to multiply by 3 on top and bottom, and that's going to give me 16/3 minus 18/3, and that'll answer my question. So then I subtract to get my numerator as -2, and then my denominator stays the same as 3. So it would be -2/3 as my answer. Okay, a hat costs $25, or actually, pause to read. So I said that S is the cost of the scarf, and H is the cost of the hat. So if the cost of a scarf is $Y less than twice the cost of a hat, that would be representing this. This equation is representing that situation. I could find the value of Y by plugging in the hat cost, the cost of the hat, which is 25. So where H is, I put 25, and the cost of the scarf as 45. So where S is, I put 45. So that's what I'm going to do. So 45 is equal to 2 times 25 minus y. So that's 45 is equal to 50 minus y. So you can already tell that y is going to equal 5 here, because 50 minus 5 gets you to 45. So y must equal 5. That's the answer. Okay, so the next one, pause to read if you haven't already. So this is the situation that's been described. Selena has 4 times as many as Carla. So S is the number Selena has. K is the number of stamps Carla has. And then Taylor has twice as many as Selena. T is the number of stamps Taylor has. And then Taylor plus Selena's number of stamps equals 120. And we want to find, basically, we're solving for K, how many Carla has. So pretty much, if I can figure out what S is, I can plug it in there and then solve for K. So I can replace T with 2S, because I know T is equal to 2S over here. So instead of T, I'm going to write 2S plus S is equal to 120. Combine my like terms to get 3 times S is equal to 120. Divide by 3 on each side, and we get that S is equal to 40. Now that I know S is equal to 40, I could say, okay, that means 40 is equal to 4 times K. So then what must K be? Well, you could technically, you already see what K could be, but you could technically divide by 4 on each side to get K completely by itself. And K equals 10. So the answer would be B. Okay, pause to read 21 if you haven't already. So if we're writing out the situation, F represents the number of books read in February, which is 16. M is the number read in March, which is 125% of the amount read in February. So 125%, because it's 25% more. would be represented by 1.25. So that's what I did, 1.25 times the amount in February. So if we want to answer the question, which is asking what fraction of the total number of books were read in March, then we would do 1.25F, March basically, over the total amount read in February plus March. So like this is the precursor, and then I kind of just went ahead and subbed in what M represents and what I could put for F plus M over here, so that I'm only left with one unknown right there. Now I can also plug in an F for F right here, or sorry, a 16 for F right here. So it becomes 1.25 times 16 and 1.25 times 16 down here. And then I can go ahead and solve. And when I do that, I get 20 over 36, which I can simplify by dividing by 4 on top and bottom. And that would give me 5/9 as my answer. Okay, let's go to 22. Pause to read if you haven't already. So I have labeled my rectangle with the width being 5, and then I just said the length is represented by L. Now remember, area of a rectangle is equal to length times width, so length times width in this case would be the L times the 5, and we know the area is 60. So it'd be 60 is equal to 5L, divide by 5 on each side to get L by itself, and you would get that L is equal to 12. So the answer would be C, 12 meters. Okay, pause to read number 23 if you haven't already. So this whole situation can be represented with this equation where H is the number of hours. So it's $40 times the number of hours plus the $50, I guess, fee for tools and supplies equals a total of $290. So we just have to solve for H. So let's subtract 50 on each side. So then that's going to be 40H is equal to 240. And then we're going to divide by 40 on each side to get H by itself. And that's going to give us that H is equal to 6. So the answer would be D. Okay, pause to read number 24 if you haven't already. So for this one, you can think of, most people would think distance is equal to rate times time, that formula. You could also just do kind of like stoichiometry to find the miles. I'm going to just use this formula. So I'm going to say that I'm looking for the distance it's traveling, and the rate is 60 miles per hour. So 60 times the time, which is 4 hours. So the distance would be 60 times 4, which is 240. C. Okay, pause to read number 25 if you haven't already. So we have a systems of equations represented by this situation. So M is the amount of hours that Marla worked. S is the amount that Sam worked. So Marla's amount of hours is equal to 9 more than Sam's, and Marla plus Sam's hours accumulate to 45 hours in total. So I want to know what S is essentially. I'm solving for S, so I need to replace M, which I can easily do because I know M is equal to S plus 9. So instead of M, I'm going to put S plus 9 in the second equation. So now I have S plus 9 plus S is equal to 45. And I could combine my terms of S and S. So now I have 2S plus 9 is equal to 45. Now I'm going to subtract 9 from each side, and I get 2S is equal to, that's going to be 36. So now I'm going to divide by 2 on each side to get S completely by itself, and that's going to give me that S is equal to 18. So the correct answer in this case would be A. Okay, now pause to read 26 if you haven't already. So this whole situation can be represented like this, where X is the the number of more males that they're going to mark. So males would be 300 males or male dolphins that have already been marked plus the X more. And then the total number would be like all the females plus all the males. So 300 plus X is the males, plus the females would be the 200 that were already marked plus the 120 more that were marked. And males to female to males to the total, male dolphins to the total dolphins has to be equal to 3/5. So we're just going to cross multiply now. And well, actually we should probably simplify this first before we cross multiply. So let's do that. So that's what we get. Now let's cross multiply. So when you cross multiply, this is what you get. And now we're going to distribute the 5. So we're going to get 5 times 300 is 1500 plus 5 times x, which is 5x, is equal to, now we're going to do 3 times 620. So that's going to be 1860. And then we're going to have plus 3 times x, so plus 3x. Okay, so I rewrote it up here because I was running out of space. So now I'm going to subtract 3x from each side. So I'm going to have 1500 plus 2x is equal to 1860. Now I'm going to subtract 1500 from each side. So I'm going to get 2x is equal to 360. Now I'm going to divide by 2 on each side, and that's going to give me that x is equal to 180, yeah. So that would be my answer, 180. Okay, pause to read number 27 if you haven't already. Okay, so if we're writing out Clara's situation, the total amount she gets paid would be represented by $15 times the number of hours, because it's $15 per hour, plus the $10 flat fee. And then Jane's situation would be $12 times the number of hours, because it's $12 per hour, plus 8 times the number of, sorry, I got a text message, $8 times the number of students. And we want these totals to be equal because they're going to have the same total amount, it said. So we're going to set these equations equal to each other. And then we're going to say, okay, we know that they're talking about 3 students, so we have to plug in 3 for S. So we have 15H plus 10 is equal to, ooh, that's a terrible 10. 15H plus 10 is equal to 12H plus 8 times 3 is going to be 24. Now let's subtract 12H from each side. So that gives us 3H plus 10 is equal to 24. Subtract 10 from each side, and we get 3H is equal to 14. Now I'm going to divide by 3 on each side to get H is equal to 14 over 3. And if I simplify that into a mixed number, that's going to go in 4 times with 2 left over. So 4 2/3 is what I get. And it says round to the nearest hour. So the nearest hour would be 5 hours. So it would be C. Okay, now 28 says, well, pause to read. So 80% of the total number of the chairs in the store has to equal 300. So 80% as a decimal would be 0.8. X is the total number of chairs in the store. And that has to equal 300, like 80% of the, did I say that right? Yeah, 80% of the total chairs in the store were sold. So that has to equal the 300 sold chairs. So now I just need to divide by 0.8 on each side to get X completely by itself. And that gives me that X is equal to 375. So that is my answer, B. Pause to read number 29 if you haven't already. So in this problem, the units can really help you out a lot. You're trying to find wild boars per square kilometer. So it's 500 wild boars per, that's related to the 10,000, sorry, a lot of people are calling me right now, 10,000 square kilometers. So if I solve this, I'm going to cross out a 0 on top, a 0 on bottom, and you're free to simplify it however you like. This is just how I do it. So 5 over 100, if I divide by 20 or by 5 on top and bottom, I'm going to get 1 over 20, which is the same thing as 0.05 right there. I mean, I didn't even actually have to do that because 5/100ths is like, you say the decimal like that, 5/100ths, because this is in the hundredths place. But yeah, sorry, I got distracted by that call. I'm gonna pray to God that I was still pressing like record when I was getting distracted by that call, because I cannot remember if I pressed the button or not. So we're gonna just hope, and then if not, it's gonna be an awkward pause right here. I don't know, it's late, sorry. And I'll just edit over this. Hopefully I remember. Okay, so pause to read number 30 if you haven't already. So what I would do here is just pick numbers. Like there's no rhyme or reason to why I picked I just picked like the first number I thought of that was easy, 100, and then subtracted 28.8 to show that I'm going from 100 degrees Fahrenheit to 71.2 degrees Fahrenheit when it's decreasing by 28. So that's what I'm plugging in for x as because x is degrees Fahrenheit. So I'm saying that I'm going from x being this to x being that, and then I'm going to see what the change is for c. So I'm basically plugging in two different scenarios. So let's start with scenario 1. So number 1, I'm finding the degrees Celsius when I plug in that my degrees Fahrenheit is 100. So 5/9 times 100 minus 32. Right there. So that's going to be 100 minus 32 is 68. 68 times 5 is 340, and then put the 9 on bottom. So situation 1, the Celsius degrees is going to be that. Now let's go to situation number 2. Remember, for our second situation, we're using the same equation, but instead of plugging in 100 for x, we're going to plug in 71.2 for x because it's gone down by 28.8 degrees Fahrenheit. So let's do that. So this is what we get when we do that. And now let's subtract this and then multiply by 5/9. So you should get 196 over 9 now. Now we want to know how much did the temperature decrease. So we're being asked essentially like how much did it change. So we're going to do the first situation minus the second situation to find the change in temperature for degrees Celsius. So 340 over 9 minus 196 over 9. So let's see. And when we do that, we get 16 as our answer. Okay, pause to read 31 if you haven't already. So this would be an equation that represents this situation. And we want to find what percent greater the value of z is than the value of y. So I'm going to divide by 15 over 20 on each side. So really I'm multiplying by 20 over 15. To get this. So z is equal to that times y. I can simplify this by dividing by 5 on top and bottom. That's going to give me 4/3 times y is equal to z. So z is equal to 4/3 times y. So I could make this into a percent by turning it into a decimal first. So I could say, okay, what is 4 divided by 3 as a decimal? And that's going to be like 1.333 yada, 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 yada. And now I'm going to turn it into a percent by moving the decimal over by, and let me just add another 3. It just kept going by 3 threes. I'm going to turn it into a percent by moving the decimal over by 2. So it's going to be 133.333 yada, yada, yada. And it says round to the nearest tenth. This is the tenths place. So I look at my neighbor. Is it 5 or greater? No. So I keep the same number in the tenths place. So it'd be 133.3 as my answer. So pause to read 32 if you haven't already. So I've rewritten out all the given information here. So we're trying to find x in this situation basically. So one thing that you want to do is look for patterns. Like with this 2 and the 3, I see that like 16 and 81 can be written as like variations of those values, those numbers. So 16 can be rewritten as 2 to the, whoops, why is that not connecting? 2 to the 4th power is the same thing as 16. And then I could say that 3 to the 4th power is the same thing as 81 as well. So now I'm going to think, okay, how could I rewrite this other stuff to my advantage? So remember, q is the same thing as p to the x power. So instead of q, I'm going to think p to the x goes there. So now I'm going to rewrite this as p to the x over 3, because if I rewrite it with a fractional exponent, the x becomes my numerator, the type of radical becomes my denominator. So the 3 is my denominator. And I'm going to do the same thing rewriting it here. So root p is the same thing as p to the 1/2. So now I have this right here. Now I'm going to see, okay, what can I do to make this work out where I could easily solve for what x is? So I know that p is the same thing as 2/3, so I could plug in 2/3 for p, so now I could have 2/4 times 2/3 to the 1/2 is equal to 3/4 times p to the x over 3. Now if I divide by 3/4 on each side, or 3 to the 4, sorry, on each side, I would get 2 to the 4th over 3 to the 4th times 2/3 to the 1/2 is equal to p to the x over 3. Now I see where I can maybe use some of my laws of exponents to rewrite this to my advantage. So 2 to the 4th over 3 to the 4th is the same thing as 2/3 to the 4th power. So now I can use product rule to say that this is the same thing as 2/3 to the 4 plus 1/2, which is just 4.5, and that has to equal p to the x over 3. Now remember, p is equal to 2/3, so I could say that this is equal to, instead of p there, 2/3 being raised to the x over 3. So if this is truly equal, 4.5 must equal x over 3. So that's what I'm going to do now. 4.5 is equal to x over 3. And if I multiply each side by 3, I'm going to get that x is equal to 13.5 as my answer.